Hi, today we are going to see about diversity combining techniques in multipath mitigation techniques. Diversity combination methods. Each branch is co-paged with the other branches, weighted by factor A, where A depends on amplitude R. Selection diversity. In this, A equal to 1 if rho greater than rho j for all j not equal to I and 0 otherwise. Equal gain combining, that is A suffix I equal to 1 for all I. Maximum ratio combining AI equal to rho I. Selection diversity. In this selection diversity, the channel select only the strongest signal. In practice, select the highest signal plus interference and noise power. Use delay and hysteresis to avoid ping pong effects, which is excessive switching back and forth. The selection diversity is simple in implementation. Threshold diversity. Switch when current power drops below the threshold value. This avoids the necessity of separate receivers for each diversity branch. The figure shows the selection diversity. The selection diversity rule is based on it selects strongest signal. Outage probability for selection diversity is PR equal to PR, in which all rho less than threshold value of rho. For L branch selection, diversity in relay fading. Selection diversity is simple and cheap. The receiver selects branch with highest instantaneous signal to noise ratio. New selection made at a time that is the reciprocal of the fading rate. This will cause the system to stay with the current signal until it is likely the signal has faded. Rho is new average signal to noise ratio power and sigma is to average SNR in each branch. A block diagram of this method is similar to space diversity. M demodulators are used to provide M diversity branches, whose gains are adjusted to provide the same average SNR for each branch. The receiver branch having the highest instantaneous SNR is connected to the demodulator. Next one is combining diversity. In selection diversity, waste signal energy by discarding copies of the received signal. This drawback is avoided by combining diversity, which exploits all available signal copies. Each signal copy is multiplied by a weight and then added up. The types of combining diversities are maximum ratio combining, in which it weights all signal copies by their amplitude, and this is an optimum combination strategy. The second one is equal gain combining, where all amplitude weights are at same. Activity. This figure shows the maximal ratio combining. Maximum ratio combining. It weights signal proportional to their amplitude. Maximum ratio combining is A suffix I equal to constant R suffix I. This is the same as matched filter. SNR at the output is the sum of the SNRs at all the input branches. Maximum ratio diversity, in which signal amplitudes are weighted according to each signal to noise ratio and is summed in phase. It is most complex of all types. A complicated mechanism, but modern DSP makes this more practical, especially in the base station receiver where battery power to perform computation is not an issue. Equal gain diversity. The equal gain diversity is a combine multiple signals into one, in which G equal to 1, but the phase is adjusted for each received signal so that the signal from each branch are co-phased. Vectors added in phase, better performance than selection diversity. The comparison is given in this slide. The assessment questions. Thank you.